So today is square roots, and it's very, very important that, all math goes together. So, every concept is a concept that needs to be learned. You need to ask questions if you're not sure what's going on. But we need to learn how to deal with roots and radicals. Roots and radicals, all right? Not tree roots and not radicals that are like protesting, but roots and radicals, mathematical ones. It's important that you know some terminology. A lot of people call the symbol here that's blue, they call it the square root symbol, and that's technically not true. It is in actuality the radical sign. And that is the first blank for underneath A as well. It's the radical sign. R-A-D-I-C-A-L, radical. The radical sign. And it's an operation sign. Like a plus sign is an operation sign. Like a raised dot tells you to multiply. It's an operational sign. So it indicates the operation of a root. It indicates the operation of a root. In the example, I have just the letter A, a variable underneath the radical sign. There could be a whole bunch of stuff under there. Mostly we'll deal with numbers right now in pre-algebra. In algebra 1, we'll deal with a lot of variables under the radical sign. But everything that's under the radical sign is called the radicand with a D on the end. So R-A-D-I-C-A-N-D, the radicand. And that's everything under the radical sign. And I'm just going to use my red there and draw an arrow to it. That's the A, the radicand. The radicand is what you take the root of. I know that's not great English, but it's beautiful math. It's what you take the root of. Right? If there was a 4 and it was a square root, we'd take the square root of the 4. You take the root of the radical. The root of the radical. Now, we'll mostly deal with square roots in pre-algebra, not exclusively. But it could be any kind of roots. That's why the symbol is a radical sign, not a square root symbol technically. Because there's other things than a square root. You can have a cube root. You can have a fourth root. You can have a 10th root. You could have a root canal, but we don't like that root, all right? So roots. And what tells you the kind of root is the index. So C is the index. I-N-D-E-X. Indicates what kind of root it is. So again, I'll just use a green arrow and go up to the N. The index, what kind of root it is. So the index is usually a number in the crevice of the radical sign. A number in the crevice of the radical sign tells you what kind of root. Now here's the thing. If no index is shown, the index is 2. But we don't show 2's. There's no such thing as a 1 index. But it can be a 2. And we don't show 2's. We just show the radical sign, and you're supposed to know the index is 2. You already know the second part. If there's no index shown, you know it's a square root. A square root. And I'll explain what all these things mean in just a moment. So make sure you know the terminology. It's important because I'll say terms like the index, I'll say radicand, I'll say radical sign. You need to know what I'm talking about. Otherwise, I might as well be talking in op language. Rop, I, gop, hop, top. Yappy, sop. Napo. Okop. That was okay. All right. If you know op language. No, but that one, you heard it enough. You heard enough there, right? Gopi, Vapi, Mapo, Napi, Yop. So you don't understand op language. Anybody say yes to that? Gapai vapi, mapo napi yap? Mapi? Thank you. How much? That was give me money. All right. Once I put the mapi on there. All right. Anyhow, point is, you need to learn the terms so that when I speak math, then you're understanding what I'm talking about. Otherwise, you won't know what in the world I'm talking about. Because math is a language. Okay, so we got index, radical sign, and radicand. Let's take a look at a couple examples here. So, what are square roots? What are square roots? Well, again, as we said a moment ago, first off, the index is 2, though you're not going to see it. But if you look right down here at number, Windows, driving me crazy. Oh, Windows. Makes me not even want to grab my magic pen and do this. Come on, magic pen, what happened? Let me try this way. There we go. You know, when you look at this, is there any index shown? Is there something in the crevice? No. And again, you're supposed to know that the index is a 2, and this is indeed a square root. So this is a square root. The index is 2, and Windows is driving me crazy here. So the index is 2. So here's what a square root means. What number times itself, and I'm going to use my green here, 2 times? Where did I ever get the 2 from? From the index. The index tells you how many times. Square roots, that would be a 2 times. If this was a cube root, I would be saying what number times itself? 3 times. If the index was 4, I would be saying what number times itself? 4 times. That's how that works. So again, the index is telling you what kind of root. Radical sign tells you it's a root. The index tells you what kind of root. So a square root is this. What number times itself 2 times equals the radicand? All right, so how many know the answer to square root of 9? How many of you know the answer? All right, the answer to the square root of 9 is 3. Do you know why it's 3?
Yes.
Well, again, here's the question. What number times itself 2 times equals 9? What number times itself 2 times equals 9? And we all say the answer is 3. But I hope you understand the reason the answer is 3 is because 3 times 3 equals 9. Right? The number times itself twice that is a 9 is the number 3. That's a square root. What number times itself 2 times is a 9. So then in the second one, square root of 25, again, most of you should know that the answer is 5. But remember, this is a square root. And now it's what number times itself 2 times equals 25. And therefore we know the answer is 5, because a 5 times itself twice, 5 times 5 equals the radicand of 25. That's square roots. Let's do a little mental math. What do you say? All right, I'm going to throw out a square root. You tell me the answer, all right? You ready? Square root of 49.
7.
Square root of 144.
12.
Square root of 100.
10.
Square root of 169.
13.
13. Square root of 225.
16.
That one's 15. All right, throwing some off-the-wall ones at you. Square root of 10.
It doesn't have one.
It does have one, but it's not an even integer. Everybody take your calculator out. Let's do one we know first. We all know the square root of 81 is? All right, so punch in 81 and hit your square root button. Some of your calculators, you got to do the 81 first, then the square root button. Others of your calculators, you got to do the square root button first, then the 81. The square root button is the radical sign. Look for a button that has the radical sign. Make sure the index isn't 3. It'll just be, there'll be no index there. Every once in a blue moon, instead of having a radical sign button, you have x to the 1/2 power, but I doubt that's the case. Those are old school calculators. Is everybody able to get 9 when you punch in the square root of 81? Anybody not find their square root button? All right, hold your calculator up to the crowd and show them what kind of calculator you have. Hold it up so they can see who has to them. Who has a calculator like that and you found it? Anybody have a calculator like hers and you found it? Brendan, show her where that button is. Just go over there. And you have the same calculator, Amber, so show them both so they see where their button is. Everybody else good? Everybody else find their button? Because it's above the button. Anything above your button, you have to use your second button. So back to the square root of 10. Go ahead and punch in square root button and 10, or 10 in the square root button, however your calculator does it. You would have gotten 3 point something, right? What do you got, 3.1? Okay, etc. See, there is a square root, but it's not, listen now, an integer. It's not an integer, but it does exist. And we're really not going to deal with square root of 10 because we don't want a round off answer, right? Wouldn't we have to round that number off because it goes on forever? So we just leave it square root of 10, but there is a square root. It's just not an even integer. Square root of 1 equals 1. Next integer root is the square root of 4, because it equals, listen now, watch now, 2. The next even root is the square root of 9, because it equals 3. The next even one would be the square root of, because it equals 4. The next would be the square root of 25, because it equals 5. Then square root of 36 is 6, 49 is 7, 64 is 8. You see how that's going, right? And those are the ones that we can get integer answers to. And you can keep going forever and ever. Amen. All right. So even roots actually have 2 answers. The positive answer is called the principal root. And this is principal like in money, the money you borrow or the money you invest. Principal, P-A-L, and I got a little L stuck off there in the end of my blank. Principal, just like the amount invested or the amount borrowed, the term is the principal root. So the positive answer is called the principal root. So the principal root for the square root of 16 is 4, right? The positive answer. But here's the reality. Since a negative times a negative equals a positive, and it does, right? The answer can also be negative. So if we're not just talking about principal roots, we could say the square root of 36 is 6. Why? Because 6 times 6 is 36. Agreed? But we could also say negative 6. Because doesn't negative 6 times negative 6 equal the radicand 36? It does. So technically, the answer is positive 6 or negative 6. But usually, to make things simpler on students, we just worry about the principal roots right now. Okay? But technically, it's plus or minus. So you should know that term, principal root. That's the positive one. We usually don't worry about the negative unless they ask for all the solutions. And hopefully that'll be clear and you'll begin to figure that out. It's another one there that I missed. Thank you. Okay, so the answer is plus 6 and negative 6. And we can write it together. A lot of times we'll do plus minus, one over top the other, 6. That means an answer of positive 6, an answer of negative 6. It's shorthand. Okay? You see plus minus 6, that's shorthand for positive 6, also negative 6, all right? All right, number 4. You can't take, and I'm going to use blue here, an even root. Let me pause. You can't take an even root. All right, what's an even root? That's an even index. Is 2 an even index? Yes. 2 is even, right? A 4 index, a 6 index, an 8 index, ... You can't take an even root. So that's what we're talking about. Let me finish and then I'll explain it more in detail. Of a negative radicand. You can't take an even root of a negative radicand. So look at our example for number 4. What kind of root is this? Just say it if you know it. No, what kind of root is it? It's a square root. Let me ask you this way. What's the index? 2. It's not shown. We know that. Say, how do I know that? I just told you that. Or I taught you that. When you don't see an index, the index is 2 and it's a square root. So it's a square root. And it's telling us what number times itself 2 times equals negative 4. Can anybody give me an answer? What do you want to use? Go ahead, Amber. What's the answer? Just say what you said. It's okay. Your mouth was moving and words were coming out of it. Okay, and that's great. So if negative 2 is the answer, right, this is what we'd have to do. Negative 2 times negative 2, correct? Right? The thing times itself 2 times. Isn't that a square root? And what is that supposed to equal? It's no, what's the radicand? It's supposed to equal negative 4. Does it? It doesn't. And therefore, negative 2 is not an answer. Can anybody else figure out how to get to negative 4? Yes, ma'am. Okay, so Christina says negative 2 times positive 2. Does that equal negative 4? Yes or no? Yes. Is that a square root? See, this isn't a square root. That's not something times itself. Can't use them. See, here's the answer. It does not exist. You know what will happen when you guys get to Algebra 1? We're going to tell you the answer is an imaginary number. It's an imaginary number. Imaginary. What's the name of our number system? No, what's the whole name of our whole number system? It has whole numbers, it has natural numbers, whole numbers, integers, rational numbers, irrational numbers, and altogether they are the
Metric system.
No. It's the name of our... We had this earlier in the year. I can teach you. You got to remember. Nia? No, it begins with an R. No. I already said rational. Quiet, please. Stop calling out. So it started at natural numbers, then whole numbers, then integers, then rational numbers and irrational numbers, and all of those together are part of the real numbers. That's our number system, the real numbers. Now there's another number system that includes imaginary numbers. You say, but they're imaginary, they're not real. Well, yeah, they're not real numbers, but they're imaginary numbers. And they'll work in math if we know what to do with them. All right, that's a whole other story for a whole other day. And you'll have to grow up and get in the other course to get it. Here's the point. You can't take a square root of a negative radicand. You can't take a 4th root of a negative radicand. You can't take the 100th root of a negative radicand. You can't take the 12th root of a negative radicand. You can't take the 54th root of a negative radicand. You cannot take an even root of a negative radicand because you can't end up with a negative answer when multiplying something times itself an even amount of times. However, we can take the cube root of a negative radicand. We'll get to that later. So hold on and we'll be there. All right, number 5. When the radicand, and I need the word is in there, when the radicand is not a perfect square, the solution is an irrational number. IRRATIONAL, an irrational number. All right, we talked already about the perfect squares. Let's just list out a bunch of them, right? 1, 4, 9, 16, right? 25, that's a 5. A 6 is a 36. A 7 is a 49. These are all things we can take the square root of it, right? 8 is a 64. 9 is an 81. 10 is a 100. 11 is a 121. 12 is a 144. 13 is a 169. Anybody know 14 times 14? I don't know that one either. I know 15 times 15 is 225, and the rest I use my calculator. What is it?
196.
196. Beautiful. Oh, 169, 196. That should be easy to remember from now on, right? And then 15 is 225, and we'll stop there, ... All right. Those are all perfect squares, and you can take the square root of any of them and get an integer, a counting number. But again, if you take the square root of a non-perfect square, you get an irrational number. Now, again, go ahead and punch in your calculator square root of 5. And depending on how many digits your calculator gives you, this is 2.236067978 at ... It goes on. It's irrational. It's a non-repeating, non-terminating decimal. Does that sound familiar? We have talked about that. Here's the thing. We can't make a fraction out of this number with an integer on the top and an integer on the bottom to exactly equal this. There's no fraction that exists. So we call it an irrational number, right? That's going to be any non-perfect square root. And we'll deal with those. So again, these are non-terminating, non-repeating decimals. Irrational numbers. However, we could say something like this. We could say that the root will be between two consecutive positive integers. Just my E in there. I'm like, what's wrong with that word? So we'll be between two positive integers. So, though we're not interested in the number 2.36067987 because it's a round off, we could say this, that the square root of 5 is somewhere between 2 and 3. So let me show you what I mean. What two integers is the square root of 59 between? Let me give you a second to think. What two integers? Like, for example, 13 and 14? 72 and 73? 1 and 2? What two integers is the square root of 53 between? Chloe, go for it. Chloe said 7 and 8. So what we want is, I want the perfect square on the left, and that's the square root of 49, which is a 7. And therefore, the perfect square on the right, which is a square root of 64, which is an 8, and that's why Chloe said 7 and 8. The square root of 53 is somewhere between 7 and 8. Why? Because the square root of 47 is the closest closest perfect square root, lower than square root of 53, and therefore square root of 64 is the next highest one, so it's got to be between 7 and 8. So that's the idea there, and that's what we're thinking about as we try to do these. So let me give you one more here. Let's do one more example over here on the right. So tell me what two integers this is between. Let's go with the square root of 103. What two integers is the square root of 103 between? Now, again, this is mental, so you could use your calculator and figure it out, but this is something you should be able to do mentally. All right? So if you're mental, you should have no problem with this. All you mental people. Got it? So what two integers is this between? 10 and 11, right? Because you have the square root of 100 lower, which is 10, and the square root of 121, which is 11, that's higher. By the way, do you expect the answer to be closer to 10 or closer to 11? Closer to 10, because 103 is closer to 100 than it is to 121. Now, that's not always a concise, direct, exact thing, but it does give you a generality. What is this for? This is for estimating, guesstimating, having a general idea of where your answer is. Okay? Somewhere between 10 and 11. In our day and age with calculators, there's not a whole lot of use for estimating anymore. You know, it used to be people didn't carry a calculator in their pocket, all right? I mean, you couldn't walk up to somebody and then pull out a calculator. It didn't happen. The only time people had calculators when they were in math class. That was it. Does everybody have a calculator with them almost today? Yeah, right? It's called their phone. So there's not as much use of estimating these days. They just pull out their phone and hit the calculator app and away they go. But it is good to have a general idea of what we're talking about. All right, number 6. Adding radicals. Adding radicals. On the kind of problems we're going to do right now, we want you to take the root, then add them. And again, normally we're just talking about the principal root. So watch how easy this first one is. Square root of 9 is? What's the square root of 1? 1. And we all know 3 plus 1 is 4. If not, you don't belong in this class. All right. Not to say there won't be a time when you have a brain cramp and say something else, but that is a 4. All right. So you can see the second problem, the same kind of problem. We all know the square root of 81 is. We all know the square root of 169 is 13. Finish that one. And therefore, we all say the final answer is -4, because 9 positives and 13 negatives leaves you 4 negatives. Take note of C here. Look at B and look at C. Do you see the difference? B is 2 radicals. C is 1 radical. With a problem like C, you need to add these up before you take a root. If you don't, you're going to get the wrong answer. Add them up first. Do any operations in the radicand first. Then take the root. We all know the square root of 144 is 12, and that's your answer. So in any situation like that, make sure you do the operation. Look, you could have addition, multiplication, all kinds of stuff, and that's what we're going to do here in these next couple of examples. All right, so 7. Don't forget to follow the order of operations. Order of operations. You know how the fraction bar is kind of a grouping symbol, technically? And so don't write this. But, you know, again, if you had a fraction, don't write this, and you had something like this. Let's do like 2 times over 5 plus 8 divided by 4. If you had a problem like that, your fraction bar is a grouping symbol, and you have a top to deal with, and you have a bottom to deal with. What order do you follow in the top? The order of operations. Let's go. We should all have this in our head always. So the order of operations is then And division left to right, and then addition and subtraction left to right. So agreed, we would do 5 cubed. 5 times 5 is 25 times 5 is 125. Then we do 2 times 125 and get 250. Then we do 250 minus 2 and get 248. That would be our top, right? You don't have to write this. I'm just giving you an example. But on the bottom, there's no exponents. We would do this division first, right? 8 divided by 4 is 2. 5 and 2 is 7. We end up with 248 over 7, and then we would finish the fraction finally. The fraction bar, here's the point, is a grouping symbol. Well, just like that, the radical sign is a grouping symbol. So underneath the radical sign, follow the order of operations. Underneath the radical sign, follow the order of operations. Okay, so if I'm doing a problem like this, I can deal right now with the square root of 9. Square root of 9 is? Now, don't say anything out loud yet because I want everybody to think. What's the relationship, don't say anything out loud, between the 5 and the 3? Just apply math principles, things we've already learned. So what is the relationship between the 5 and the 3? Basically, the question is, are we adding the 5 and the 3, or are we multiplying the 5 and the 3? That's basically, you should boil it down to those two possibilities. Are we adding or are we multiplying? And the answer is we are multiplying, because anything written next to a parentheses, same thing with written next to a radical. This is multiplication. That's going to be 5 times 3. Now in our second, by the way, this is the way your work should look on any homework problems like this. Hey, before we do anything, we got to do the 29 minus 4, right? And we got to get 25. And I can begin to do the next line. 5 times 3 is 15. But on the left, I still have to do the 2, and then we all know the square root of 25 is 5. Does that make sense what I'm doing? Just taking it one step at a time? So you can see this thing ends up being 15 minus 10, right? And the final answer is 5. Does that make sense to everybody? Just treat the radical sign as a grouping symbol, okay? All right, so let's wrap up with B. See if you guys can take B as far as possible. And I'm going to pause and let you guys see what you can do. So hopefully everybody said 4 times 9 is 36. And we all know the square root of 36 is 6, but don't forget that negative in front, right? Right now the top is a negative 6. Did you get a negative 6 in the top to begin with? So on the bottom, negative 10 and positive 54 leaves a positive 144, and therefore the bottom is a 12. And surely you reduced, right? And final answer would be negative 1/2. How many got that right? Okay. That's all we're dealing with right now. Terminology, understanding that a square root is what number times itself 2 times equals the radicand. We talked about, look, every time we took the root, we found what kind of answer? When I said the square root of 36 is 6, that's actually the what root? It's the principal root of the square root, right? Technically, it could be plus or minus 6. We normally just deal with the principal root, the positive part of it. Square root of 144 technically is plus 12 minus 12. We usually just deal with the principal root unless you're told otherwise. But don't forget, the principal root is the positive one. Radicand, index, radical sign, learn those things. Homework tonight,